I love my 3D printers, but in the back of my mind, I know that they are quietly emitting all kinds of nasty pollutants and cancer-causing compounds. And even if you only print PLA, the same is true of your 3D printer or printers. That's why in this video, we're going to see if and how we can drastically improve the air quality in my workspace and yours with affordable consumer-grade products. Let's get after it. So, I don't know if it was the 2 separate severe sinus infections that I've gotten since moving into this studio, reading a book about the history of some particularly nasty cancer cells, or just seeing how many precautions the manufacturers of these 3D printers actually take in their own workspaces, but I've been thinking a lot about air quality lately. And while there seems to be a general attitude of brushing aside concerns about air quality, especially for people who don't do a lot of ABS printing, a recent video by friend and fellow YouTuber Lost in Tech really caught my attention. In it, he built a sort of makeshift air quality logging device, which then showed just how dramatic the VOC, or volatile organic compound emissions, are for things like ABS, which is becoming more and more popular with the increased popularity of closed printers. And of course, that's not even considering the PM2.5, or microscopic particles emitted from other activities, such as sanding your prints, soldering, and so on. But perhaps even more alarmingly, his video showed a surprising amount of VOCs being emitted during the preheating stages of the so-called safer materials, things like PLA and PETG, due to the need to burn the leftover material out of the nozzle. Oh, and by the way, if you haven't already seen Lost in Tech's channel, I will link to it below so you can check it out, ideally in a new tab, because I'm going to be referring to it a few times throughout this video. Case in point, there was one major idea and takeaway from that video that caught my attention. Lost in Tech pointed out that every study that has looked into the relationships between air quality and 3D printing has emphasized the importance of just changing and circulating the air in the environment. Sure, it's much sexier and much more fun to build our own clever little air filtration systems like the Nevermore or the Bento Box and so on. I love those solutions and I've used them extensively in the past, and I continue to do so, whether it's on my Voron machines or my Bamboo Lab printers. And as I'll explain later on in the video, I think that these homemade solutions can and should be a very important part of an overall larger clean air strategy. But there are a few issues with using them exclusively. First of all, not all printers are enclosed. And second of all, even for those that are enclosed, without having sensors inside the print chamber to monitor air quality, we actually have no way of knowing if and when the air has circulated through the filtering medium, whether that's HEPA or activated charcoal or even both, enough times to deem it safe. Chances are, if you're as impatient as I am, you're going to want to open up the printer either to wipe away the purged material from the nozzle or to remove a completed model well before the air inside is fully filtered, which means you'll still be exposed to VOCs and fine particulate matter. Not to mention the fact that none of these printers are truly airtight, and some nasty stuff will always escape before filtration. Also, as Lost in Tech pointed out to me when I reached out to him personally, carbon is very effective, but it expires very quickly, and you have no good way of knowing when it's reached saturation. That means that you could easily be using the same carbon well after it is already saturated, making it basically useless without you having any real way of actually knowing. So yeah, filtration is fine, but circulation is just as important, if not more so, if you want to improve your air quality. This makes sense if you think about it. I mean, filtering the air is good, but not quite as good as completely replacing the air with clean, fresh air and letting Mother Nature deal with our nasty-ass VOCs. At least, that's what I thought before embarking on this video. But more on that in a bit. Either way, I don't know about you, but personally, I'm not an engineer and I don't know too much about CFM, airflow, and all of that. I'm just a dude who likes 3D printing and would like to live long enough to see our AI overlords destroy our species. So with that in mind, I set about doing some super professional, thorough, and diligent citizen science. I'm just kidding. You guys know me. I don't have the patience of a CNC kitchen or a Lost in Tech, and I barely passed high school chemistry. So instead, I decided to partner with DREO, who agreed to sponsor this video, but more importantly, to send me one of their smart air circulation fans for testing. These are ideal for this type of test because beyond the fact that they collect to you-know-who and Google Home and can be programmed to work with your smart home, they also oscillate up and down, side to side, and all that good stuff. I also love that these products are web-enabled so that I didn't have to wait here all day and night to turn them on and turn them off when I'm not at the studio, but want to filter the air. More on that in a minute. And because I'm not so good with the whole building custom electronics and using them to log data thing like some of my contemporaries are, I also asked DREO to send over this smart air filtration system so that I could use it to measure and generate air quality graphs right inside of the smartphone app to show all of you, and if needed, supplement my circulation tests with air filtration tests to compare and contrast the different strategies for getting clean air in my workspace. Plus, for good measure, since the DREO filtration system judges air quality using PM 2.5, I also supplemented my citizen science with just a cheap air quality sensor which measures VOC, which I did verify to be working effectively. So, my original plan was to reach peak level of air pollution by printing ABS and ASA, loading and unloading filament, drying old filament, and then test various different scenarios for cleaning the air to see which was the most effective and efficient. I figured that I would try the circulating air versus pushing dirty air out the window versus creating an inlet and an outlet to channel air through the room, and then finally do the same but in reverse, pumping clean air in. And then I would just measure how quickly the graphs from the DREO app showed air quality improvements, labeling each one of the scenarios to then come up with my ideal recommendations for cleaning the air in your workspace. My God, that was a long sentence. Unfortunately, that's not what happened at all, and soon as Lost in Tech tried to warn me, I was down the frustrating and confusing rabbit hole that is air quality testing. With that said, while I wasn't able to come out with a clear and easy-to-follow prescription for improving air quality, my lack of success did dredge up a lot of surprising learnings and takeaways, and I think that those are very much worth sharing. So here's what I found out. Number one, ABS and ASA printing are likely the least of your worries. This was the first and certainly the biggest surprise of this entire project. See, going into this, I had assumed, as most people on places like Reddit and Facebook would have you believe, that ABS and ASA are the biggest threats to air quality in any 3D printing maker's space. Therefore, one may logically assume that if you don't print those materials, you have nothing to worry about, right? But listen up. If you take away just one thing from this whole video, it should be this. When it comes to air quality in your makerspace, you have much bigger fish to fry. Throughout my testing, I struggled to make a dent in the air quality, either PM 2.5 or VOCs, by simply printing ABS on all my printers. In fact, I almost came to the conclusion that, heck, maybe if you're in a big enough room printing relatively dry filament, this isn't as big of a deal as people may think. And then I realized, as makers, the vast majority of us don't just 3D print things, do we? I mean, you may or may not have an open diode laser, a resin 3D printer, a table saw, or any of the other obvious polluters that I have kicking around in my workspace. But I bet dollars to donuts that you do a little soldering from time to time, don't you? Or drying filament in a filament dryer, or putting in heat set inserts, or using harsh chemicals such as 3D gloop, or epoxy, or acetone, or even rubbing alcohol to post-process or assemble or clean your prints or printers. And from all of my admittedly imperfect, limited, and unscientific testing, these things all add up little by little to create a very, very polluted environment in your workspace. To illustrate this, have a look at the chart for my first day of testing with the DREO purifier, wherein I printed tons of ABS and ASA during the entire workday. Very little impact on air quality, right? But then I left the printers running overnight alongside a filament dryer with 4 rolls of particularly waterlogged filament of various different sorts and types in a sealed room expecting to come back to excellent air quality. Instead, I was shocked to find that the air quality had plummeted overnight. I then continued testing the overall air quality of my larger workspace outside of the print farm with all of these other complementary activities, from gluing prints together to soldering and doing heat set inserts, and I was shocked to find out just how disgusting the air in my workspace became. Which leads me to point number 2. Replacing polluted air is absolutely crucial. There are probably no surprises here. Those will come at point number 4. But if you are adding pollutants in your workspace, particularly if those pollutants are volatile organic compounds, you need to move those things out of your workspace and away from your lungs as quickly as possible. Sure, you can and probably should wear a respirator with the appropriate organic compound filters while you're working with those materials. But you're still going to want to take the respirator off at some point. And when you do, you're going to want to ensure that as much of those volatile organic compounds have been moved out of the window as possible. This point was really driven home to me during my visits to various R&D workshops in China, where I saw how seriously fume extraction is taken and the types of large systems that were being used to clear things like resin fumes from the room. In fact, I even discovered that Anycubic actually moved all their resin R&D to another facility entirely. The bottom line, if you, like me, believe that cracking a window is enough to move out all of those pollutants, it's not. You need to create a lot of air circulation, ideally moving the air around in random patterns like DREO's air circulation fans can do for you, and then pushing it out of the window with another inlet like a door on the other side of the space so that air can flow in freely. By the way, editing Jonathan here, because I just want to add that since recording this video, Lost in Tech referred me to 2 excellent YouTube videos, which I will link in the description. Those videos prove in a much more scientific way than I have here that, number 1, putting the fan farther away from the window is actually much better for airflow, which probably explains why I didn't get the results that I expected during my testing, and 2, that these DREO fans do provide significantly much more airflow than much larger or even purpose-built fans. So make sure to check out the link in the description to those videos, because more airflow is really, really important for actually ventilating and clearing out all that bad stuff, which is kind of the point of this whole video. All right, let's get back to the main video. With that said, we do need to get to point number 3, which is that clearing out accumulated nastiness takes a long time. In my naivete, I thought that I would just prop up one of these fans near a window, crank up the speed, oscillate a little bit, open a door, and within 30 minutes, the air quality would be back to excellent. In fact, as I mentioned before, I actually based my entire video strategy on it, planning to just compare and contrast the speed of each of the different positions of the fan, door, window, etc. to see which method was the fastest. I was dead wrong. Invariably, whether it was from printing ABS, drying filament, using the table saw, or soldering, I quickly realized that if I let pollutants accumulate in the room, it took a long, long time, like overnight in most cases, to bring that air quality back to normal. Now, this was true no matter which strategy I employed, from pointing the fan inwards, outwards, oscillating, static, or even simply trying to seal off the room and then filter the air inside it using the automatic feature of the air purifier. I repeatedly found that once you've let the air pollution accumulate, it takes a long time to adequately clean out that air. Now, I can only assume that this has to do with the random patterns of airflow. For example, polluted air can get stuck in the corners of the room, or maybe that it takes multiple passes of air through the filter to be completely scrubbed. Now, you may come to different conclusions from this than I did, so let's discuss in the comments below, because as I said, I am not a scientist or an expert. But personally, I took away 2 major lessons from this point. First is that I should do everything I can to prevent air pollution from concentrating in the room in the first place, for example, by using an air filter like the Nevermore or Bento box, or just a proper air purifier while doing things like soldering or gluing. And again, a powerful fan really helps to circulate the air around the room and out the window whenever I'm doing anything that could significantly pollute the air. Second, I came to the conclusion that if I plan to do something particularly noxious, such as moving my resin prints from the printer to the alcohol bath, or soldering, or using the laser, or burning a clog out of my printer's nozzle, I should be doing those activities at the end of the day so that there is adequate time for the air quality to rebound before I'm back in there breathing the air again. And while I once again want to acknowledge that my methods are far less than scientific, I hope that if you take away just 2 points from this video, that should be the second one. Takeaway number 4, the air outside may not be as pure as you think. Now let's get to the other major surprise of this whole experience. As I mentioned, I expected to open up the windows and doors, move the air out of the room using the powerful DREO circulating fan, and watch as the PM 2.5 reading on my air purifier precipitously fell. But that's not what happened. In fact, I was so confused and frustrated, I even reached out to DREO to see if I was doing something wrong with the air purifier or maybe I had a defective unit. It was at this point that DREO's customer care brought to my attention the now obvious. It's entirely possible, even likely, that the air outside my workspace is just adding more PM 2.5 pollutants. Now look, you might live in a forest in rural Colorado surrounded by nothing but trees, lakes, forests, and chirping birds. But unfortunately, I don't. I live in the city center of Tel Aviv, which is currently undergoing a massive construction boom. Just within a 100-meter radius of my studio, there are no less than 4 major construction projects going on, which involve knocking down buildings, digging deep underground, pouring concrete, welding rebar, and tons of other stuff that result in a lot of dust and airborne pollutants. And I'm not sure why I didn't think of this before. Practically every single day, there's a layer of dust on my garden furniture so thick that I've pretty much given up on keeping things out there clean. And this was my final big aha moment. Yes, if you live somewhere where the air is clean, you can probably rely just on circulation and ventilation alone to move the bad stuff out and get clean air in. But most of us don't live in a mystical enchanted meadow. We live in big cities full of pollutants and cars and smog, and the air outside may not be all that much better than the air inside, at least when it comes to fine particles. So, actionable advice going forward. I'm still processing exactly what I want to do with all of this information, but in the interim, I think I've adopted a sort of multi-pronged strategy for cleaning up the air in my studio. First and foremost, I'm going to be a whole lot more conscientious about air quality as a whole, and I'll be leaving this DREO air purifier on auto mode at all times, even when I'm not here, so that it purifies the air automatically based on how polluted it is, without me needing to intervene or actually be there to breathe in the air if it's polluted. And so that at a glance, whether by looking at the machine itself or pulling it up on the smartphone app in the morning before I plan to head into the office and start breathing that air, I can see exactly what kind of air quality awaits me. But beyond that, I think my main strategy going forward is going to be one of vent, then purify. In other words, rather than shutting all the doors and windows to keep out the hot, humid air and protect my filament, I plan on opening up a whole lot more and consistently using DREO's powerful air circulation fan to move polluted air out and replace it by way of another window open on the other side of the studio with less polluted, at least less polluted with VOCs, air from outside. Then, once I've adequately moved the most toxic compounds out from whatever activities I was doing, I'll be once again closing everything up and purifying the air that I've brought in to remove fine particles. What's more, I'm going to be making a much more deliberate effort to engage in the worst offenders, things like laser cutting, sawing, soldering, and gluing towards the end of the day so that there is adequate time overnight to clear out the air in my studio. Come to think of it, speaking of overnight, I think I probably need to get one of these in my bedroom as well because those same particles are following me home where there's even more construction across the street. But hey, those are just my conclusions from my admittedly flawed methods. I'd love if we could spark up a discussion about this either in the comments below or on the Next Layers Discord server where we already have the #workstations channel, which is perfect for discussing topics just like this. I'm sure some of you out there have a lot to contribute to this discussion, and hopefully I can do a follow-up video as I learn more about air quality, because I think it's an important topic that isn't discussed nearly enough. Really quickly, I do want to once again give a huge thanks to DREO for sponsoring this video so I could afford to devote the time to an important subject like this, even though the YouTube algorithm probably won't reward it as much as more 3D printed storage stuff. Make sure to check out their awesome products, particularly their air circulation fans and air purifiers, using the link in the description. Oh, and of course, thank you to my Patreon supporters. That's all for this week, but I'll see all of you on the next layer.